In this video, we discuss learning outcome number 3, which is all about computing quartiles and a 5-number summary for a given data set. So quartiles are just specific percentiles. We denote them by Q sub 1, Q sub 2, and Q sub 3. And they basically divide our data set into 4 groups, and you'll have 25% of the values approximately within each group. These are just percentiles that we are choosing to focus on. So that first quartile is the same as that 25th percentile. It separates the bottom 25% from the top 75% approximately. The second quartile separates the top 50% from the bottom 50%. That's the same as the median. So we're going to find that. And then the third quartile separates that bottom 75% from that top 25%. Now, because there is no consistent way that percentiles are calculated, there's no consistent way that quartiles are calculated, we are going to use the same method to compute quartiles that we used to compute percentiles in the previous lesson. But yeah, if you use different software or if you use different programs, those are going to give you different values for these percentiles. It's going to be close, but it's not necessarily going to be the same. Now, I love this graph because I think it shows visually that we've got a minimum, then the first quartile, then the second quartile, then the third quartile, and then the maximum. But what I don't love about this graph is that it shows that this 25%, this 25%, this 25%, and this 25% are evenly spaced. The minimum value, the first quartile, the second quartile, the third quartile, and the maximum are not necessarily evenly spaced. You could have that 25% that lies in between that 25th percentile or the first quartile and that 50th percentile or the second quartile. That could be a very small range of values that contains 25% of our data. Or you could have a large range of values that contains 25% of our data. So what's great about this is it makes the idea visual. What's bad about this is it says that the quartiles are typically evenly spaced, which they're not. We're going to graph a summary like this in the next, when we're studying the next learning outcome, which is about Boxplots. But for right now, in this video, we're talking about how to compute those quartiles and then how to find a 5-number summary of our data set. Now, in addition to the quartiles and the 5-number summary, which we're about to get into, there are some other statistics that are defined using quartiles and percentiles. The interquartile range is the difference between that third quartile and that first quartile. So it's the range that goes from that 25th percentile to the 75th percentile. We're saying what is the difference between that 75th percentile value and that 25th percentile value? That's the interquartile range. The semi-interquartile range is just half of that. The mid-quartile range is the mean. So it's the number halfway in between that 25th percentile and that 75th percentile. Now, that number halfway in between the 25th and the 75th is not necessarily the 50th percentile, but it's halfway in between those two values. So we'll add them together and divide by 2. So you're basically calculating the mean of those two values. And then we've got the 10-90 quartile range, which is just taking that 90th percentile and subtracting the value at the 10th percentile. So these are all ranges or values. They're going to be differences in actual data values in our data set. I don't want you to confuse the percentile with the value that is at that percentile. If we're at the 25th percentile, it's not necessarily the value is 25. The 25th percentile is the value that separates the bottom 25 from the top 75. And we also call that 25th percentile the first quartile. So if you're comfortable with percentiles, you can compute quartiles as well, because they're just the 25th, the 50th, and the 75th percentile. Now let's talk about this 5-number summary. This is the basis for the box plots that we're going to be looking at in the next video. But it's basically 5 numbers that summarize the way those data values in our data set are related to each other. So you've got the minimum value, then you look at the first quartile, the second quartile, and the third. And then finally, we have the maximum. So if I have those 5 numbers, that shows me the entire range of values. It shows me the smallest value and the largest value. But it also shows me where the bottom 25% of the values lie, and where the next 25% of the values lie, and where the next 25% of the values lie, and then where finally the last 25% of the values lie. So this is very helpful in summarizing how that data is distributed, or how that data varies and how these numbers compare to each other when we look at them all together. So let's calculate a 5-number summary for a data set. Since in this example, we're asked to use the Verizon Airport data speeds to find a 5-number summary. Notice that the data has already been sorted for us, so that makes it pretty easy to find the maximum and the minimum values. If it wasn't sorted, we could just download the data into Excel or do some data entry, put the data in Excel, and then just drag and drop that in that column, highlight all the values, and ask it Excel to sort the values for us. And so since this is already sorted, it's easy to find that top number and the bottom number. The minimum value is 0.8 megabits per second, and the maximum value is 77.8 megabits per second. Now we just have to find the second quartile, the first quartile, the second quartile, and the third quartile, which correspond again to the 25th percentile, the 50th percentile, and the 75th percentile. Okay, to find that 25th percentile, remember how we do this. The first thing we do is we calculate our locator. Now the locator is given by this formula, but I'd really like you to think of it differently. Since we're looking at the 25th percentile, K is equal to 25. Since we've got 50 values on our list, we've got 10 columns and 5 rows, so we have 50 values. N is equal to 50. But when I think of the locator, I'm thinking, I want to know what is like 25% of the way through that list of 50 values. So I'm taking that K over 100, or the 25 over 100, but that's just the same as this 0.25. That's 25% in decimal form. So I'm trying to get 25% of the way through my list of data. If I've got 50 values, I take 25% of 50, and that gives me 12.5. So that's my locator. Now remember, we handle locators that are whole numbers differently from locators that are not whole numbers. If it's not a whole number, we round up no matter what. Even if it was 12.1, I would be rounding up to 13. So I see I've got a non-whole number here. It's 12.5, so I'm going to round up to 13. And remember what that 13 tells us. We're going to go to the 13th value on our list. That's going to be the value of that first quartile or 25th percentile, same thing. So since this is already sorted, it's not too bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is in the first row. And then we've got 11, 12, and 13 in that second row. So 7.9 is our first quartile, or the 25th percentile, and that's 7.9 megabits per second. To find the 50th percentile, which is the same as the second quartile, we basically want to get half of the way, or 50% of the way, through our list of 50 data values. So we find that locator again. K is equal to 50 because we're interested in the 50th percentile. So we're doing 50 divided by 100 times N, which is the sample size, or the number of data values we have on our list. Again, if I use this formula, I'm just plugging in the 50 here because of the 50th percentile, and I'm plugging in 50 here because I've got 50 values on my list. But I'd rather not think of it in terms of a formula. I'd rather think of it as saying, I want to get halfway through the list. I want to get 50% of the way through the list of 50 values. Well, what's 50% of 50? Well, it's just the same as taking that 50 divided by 100, which is our 50%, or which represents 50% in the form of a fraction, or we can call this 0.50, which is 50% in decimal form. And I'm multiplying that 50% by the sample size, which happens to be 50. So we multiply them together, half of 50 is 25. So that's our locator. Now, since this is a whole number, we are not interested in the 25th value. We're going to compute the mean of the 25th value and the 26th value. And that is going to be our second quartile or 50th percentile. Same thing, it happens to be the median. Now remember what we said when we were talking about calculating the median earlier, when we were discussing measures of center. We said if the number of values is even, like n equals 50 is even, you take the middle two values and you find their mean. That's exactly what we're doing here. If L is a whole number, that means the number of values is even, at least in this case when we're talking about that 50th percentile. That means the number of values is even, so we're going to take the mean of that value and the one after it. So the 25th and 26th values, and that's giving us our 50th percentile or second quartile or median. All the same thing. If I were calculating the median, I'd look for the two middle values and then I would average them because n is even. If I'm looking for the 50th percentile, if L is a whole number, we take that value and the one after it and we find the mean. Either way, we're getting 13.9 megabits per second as our second quartile. So I'm just taking these guys, adding them together and dividing by 2 to get the second quartile, which is the same as the 50th percentile. And the 50th percentile, again, separates that bottom half from the top half, or that bottom 50% from the top 50%, which is exactly what the median does. To get the third quartile, I want to get 75% of the way through my list of 50 data values. So I take that 75% in decimal form, which is the same as 75 over 100, or 0.75 times my number of values. So I take 75% of 50 and I get 37.5. So that's not a whole number. That means I'm going to round up to 38 and look at the 38th value on my list. So there are 10 items in every row. So this is values 1 through 10. And then these are the 11th through the 20th values. And then these are the 21st through the 30th. And this is the 31st through the 40th. So that would make this 39 and that would make this 38. So the 38th value is that 21.5. We go to the 38th value on the list in that sorted list and we find 21.5 megabits per second. That is our third quartile, which is the same as the 75th percentile. Okay, so now we've got the max, the min, and those 3 quartiles. And that's our 5-number summary. So our 5-number summary is 0.8, 7.9, 13.9, 21.5, and 77.5. All of these are in megabits per second. So this gives us some sense of that range of values that we were talking about before. But now it also shows us how these values are related to each other. It says the bottom 25% of values lie between 0.8 and 7.9. And like the next 25%, from the 25th percentile to the 50th percentile, all of those values lie between 7.9 and the mean of these two values, which happens to be 13.9. And then that 50th percentile to the 75th percentile, that tells us where that next chunk of 25% of the values lies. It lies between 13.9 and 21.5. And then that top 25% lies between 21.5 and 77.8. So these are measures of relative standing. It shows us where these values lie compared to the other values. Now we're going to graph this and we're going to see this better visually when we talk about box plots in the next video.